Firstly, good morning, everyone. I'm really excited to be here with you today. So, today I'm going to talk about AI agents and framework. When I was first learning about AI agents, I was really amazed by how they are changing our world. So, let's talk about that now. So, First, let me tell you what's happening in the AI world right now. So you might have heard about ChatGPT. So everyone is using ChatGPT, right? And we all heard about self-driving cars, right? So these are like AI agents. So the market for AI agents is really growing super fast. So in fact, many companies like Amazon, Google, Apple, so they are using AI agents every day to help their customers, right? So let me give you a simple example from our daily life. So we are all of the people are using Instagram, right? So we are scrolling through the Instagram feed, right? So AI agents are working behind the scenes here. So that means it will show you the post you might like. So based on your likes, based on your shares, comments, it may show you the post which are very relevant, right? So they are like friendly helpers who learn what you enjoy and try to find more about it. So you see, like these AI agents are basically some smarter computer programs that can understand what's happening around them, so make decisions on their own, learn from their experiences, just like how we humans learn from our experiences, right? So these AI agents, so we use today, are just the beginning here. So in the next few years, we will see them helping us in the ways we haven't even imagined yet. Now, in the rest of our session, we are going to explore how these AI agents work, when they are being used, and even look at some real examples. So, like, don't worry, like, some of this seems to be complicated at first. So, I'll try to break down everything down to simpler pieces so that it is easy to understand. So, you know how we have different people using different jobs. So like how a chef cooks food, a doctor treats patients, a teacher teaches students. Well, AI agents are like that too. They are designed to do specific jobs but in a more smarter way than humans. We might heard about robotic waiters in restaurants. So these AI agents can able to find its way around tables. So it can able to take orders from the customers. It can bring food without dropping it, right? Even it says enjoy your meal. It can able to talk to us, right? So this robot is an AI agent here. It can see what's around it and think about what it can do, and then it will do it, right? The cool thing is these AI agents work together. So remember, um, when you learn something new in the class, you listen to your teacher, right? Firstly, you listen to your teacher. That's like the perception. So that's the perception module of an AI agent. Then after listening to your teacher, you might think about it. So that's the reasoning module of your AI agent. And finally, you try to answer some questions or do some homework, right? That's an action module. So all these are interrelated. So how these AI agents works in our real cases is like your phone understanding your voice commands, Netflix suggesting movies you might like, and also smart homes adjusting temperatures when you're coming home. These are some real examples which we are seeing in our daily life. So the amazing thing here is these AI agents getting better over time. Like just like how we better at playing game, the more you practice, the more you can able to perform, right? So these AI agents improve as they do their jobs more and more. Okay, remember, like understanding these basic things help us to see like how AI agents work everywhere around us. It's not a magic, so it's just smart technology working step by step, kind of like how we that means humans think and act. So let's talk about where we can find AI agents in our everyday life. So this is really exciting because you're probably using some of this without even realizing it, right? First, let's talk about virtual assistant. So when we ask our assistant like what's the weather, it will generate some response, right? So these AI agents acts like a personal helpers to us. You know what's amazing here? They just don't understand what you're saying. They understand what you mean, right? So it can able to understand why you are asking the weather, whether you might want to go outside or you want to plan some action, right? It can able to understand what you mean. Now the other thing is self-driving cars. So we all know about Tesla cars, right? So these cars are like a super careful driver, like who never gets tired. So this is like AI agent. So this car can able to see other cars just like we do. It read the road signs. It even predict when another car is coming or not, which is very close to us or not. Imagine like having eyes that we can look in all directions at once. So these cars can do that. So it is having all the eyes around it. Right? And next one is robotics. Well, most robots are actually doing more ordinary, but very super helpful jobs. So, for example, take warehouse. So, in warehouse, these AI agents help us to find products in the very huge building. So, it can pick up the boxes without dropping them. Also, it works 24 by 7, right? Without getting tired. It's like having a helper with super strength, with a perfect memory. It remembers everything. It can do whatever it wants. And finally, chatbots. So everyone might have talked with chatbot, right? In some real world cases. So these chatbots are getting so good. So that sometimes it's hard to tell if you're talking to a computer or a person. That's how well these chatbots are optimized now. Now let's talk about different AI agent framework. Different people might take decisions differently, right? So some people act quickly based on the situation, while others like to plan everything carefully. AI agents are exactly the same here. Let me explain you different AI agent frameworks. Firstly, we have reactive agents. These are like a goalkeeper in a soccer game. So they see the ball coming and just react based on that. So it won't think about any past or future situation. It just see the ball and it just react according to it. So they are like super quick, but are very quick, very quick, but it is pretty simple. Like uh, take an example of microwave. When you press the start button, it just turns on, right? So no thinking needed here. When you press the button, it will just start. That is the reactive agents. So next is model based agents. So these are like chess players. We all know chess game, right? So these agents are like chess players who remember the past moves and try to predict what will happen next. Imagine like playing chess. You don't just look at where the pieces are now, right? You might think about what might happen in the next few moves. That's what these agents do. Think about the past and future situations. Honesty is a goal oriented agents. So these are like me. So these are like me actually. So when I'm hungry, I have a goal to get some food. I'll plan to achieve it. So if I'm hungry, I'll go to cafeteria, I'll order some food, or else I'll make food for me, right? So this is a goal oriented. Goal oriented means having a goal and achieving that goal. Finally, we have utility based agents. So these are like your mom trying to plan the perfect vacation for you. Uh, so when we are going to vacation, we think about everything, right? So the what's the price, what's the weather conditions, what are the hotel ratings, and what are the flight timings, everything. Right? They want to make the we want to make everything the perfect choice. So just like how Netflix recommendations recommends to you, it's all about watching your habits to to suggest the perfect show. Right. Next we are to next we are going to see the uses of AI agents in different fields. Let's start with healthcare. So imagine you are not feeling well and you go to the doctor. AI agents are already there here. So it can able to look at the X-rays to help doctors spot the problems. Also, it will suggest you the best treatments based on the millions of past cases. It even predicting when someone might get sick before based on the conditions. It even predict the person might get sick based on these conditions and all. And next is finance. These finance agents like super careful security agents who watch for unusual spendings. It can protect against fraud, even help people make better investment decisions. It's like it's all about like managing your banking, managing your reports, and detecting some fraud things and all. And moving to education, AI agents are becoming like personal tutor to us. They can figure out what subjects you may find difficult. It may give you some extra practice in those areas. Also, it adjusts how they teach based on how you learn, right? So it can adjust itself. So it will teach you based on how you learn. It's like having a teacher who's available 24 by 7 for you and know exactly how to help you. In retail industry, like every one of us really wonder how Amazon recommends products to customers. That's an AI agent do the job. It's like having a friend who remembers everything that you like. It notices patterns in what you buy, and it suggests you based on your patterns. And finally, transportation. AI agents, it can able to control traffic lights to reduce the traffic jams. It helps airlines to reduce the fuel. It even plan the entire city transportation system for you. That's the power of AI agents. So the LangGraph framework. So before we understand what is LangGraph, let's understand what are different AI agent frameworks. So up to now we discussed about AI agents, right? So let's now see how to create this AI agents. So there are different AI agent frameworks available in the market right now. So now we see few of them. So first thing is LangChain. So this is like the grandfather of your modern AI agent frameworks. So this is the basic setup. It was one of the very first to make building AI agents, and it is great for creating chain of AI operations. And next, you have AutoGen. This is the Microsoft contribution to the AI agent framework. So thinking of like having a team of AI agents that can talk to each other, solve problem together, even code together, right? And the other framework is Crew AI. So this is the new framework. So Crew AI is all about again like making multi-agent system super easy to build, focusing on teamwork between agents. It can communicate from one agent to other agent. So it is very great for complex workflows. And there are many in the market. Um, but now today we'll try to understand about LangGraph. If I want to tell what is LangGraph, then I'll say it as a framework for building agentic applications. So the LangGraph basically utilize graph-based structure to manage and execute complex workflows. So we know about graphs, right? It contains nodes and edges. So this LangGraph creates graphs with nodes and edges. Here every node is an agent here. It is expected to do some different tasks and is connected to another node. That means one node is connected to another node. That means one agent is connected to another agent. Here node means your agent. It will do some tasks for you, and all are interrelated. So these AI agents are sharing the work together. So where every node is specialized with some tasks. So if you want to implement this in a code, then the entire logic, entire agent logic and the flow can be represented as a graph with cycles. The cycles means it can able to perform iterative tasks as well. So in a quick summary, it's a graph-based framework where it contains nodes and edges, where every node represents an every agent. All the agents are interrelated, interconnected. It may pass the information to another agent so that another agent can able to process the information from there and finally give you the output what you want. So let's understand this LangGraph framework with a real world example. Um, let's imagine your team of agents predicting the weather for you. Okay. Now you go to your chat GPT or you go to this LangGraph model and you are asking it, so should I take an umbrella today? Now the node one in your graph, which means your agent one, here it understands you're asking about an umbrella and also it understands you're asking about weather. So, right? Here the AI means your LLM model. So you need to connect any of the LLM model which is available to your agents. Okay. Now node 2, which is nothing but your agent 2. It connects this to the weather data and your location. So the agent 2 will will try to access your location and it fetches the weather for you. And the agent 3, so it will analyze the situation. It will analyze the weather and it will analyze your location and it gives the information. If the rain probability is high, then it will says yeah, umbrella needed. And finally you are getting some output, right? So you are asking, should I take an umbrella today? So the agent 1, agent 2, agent 3, what these agents are doing here? So it is going to access your location and going to access the weather, and it tries to find whether you required umbrella or not, right? This is how the team of agents works, doing each task by different agent. So this is the graph structure. So first you'll start, and then understanding the query, getting the weather, analyzing the weather, and giving the output. So next, importance on components of LangChain. So LangGraph is actually, I'm sorry, it's LangGraph. LangGraph is made up of several parts that work smoothly, everything together. Firstly, natural language processing. So it can able to understand the user query and turns it to a format the system can able to understand. So we can able to understand the text, right? But the computer understand only the numerical things, right? And this information is stored in the knowledge graph, which means your central database for easy access. And then this information applies some rules and make some conclusions for you based on your query. Going to the applications of this lang graph, firstly customer support. So we might have chatted with the website help center, right? LangGraph makes the chat actually really helpful. So the AI agent not only understand our problem, right, but it can able to remember my previous iterations. Let's imagine it's an online e-commerce site. So you are asking some question. It can able to, for example, you want to know your orders. It can able to fetch your order, fetch your purchases based on your data. So it also can able to redirect to human if needed. So here every task can be assigned to different agents. So all the agents are working together to support you. And finally, your query will be resolved. Let's talk about research and developments. So this is where it gets mind blowing. Scientists are widely using this slang graph to read thousands of research papers in minute. It find connections between the research papers that human might miss. So reading thousands of research papers by human is a really difficult task, but these AI agents can able to do it. And so this total concept of LangChain, LangGraph, all these have the ability to understand and read research papers. So, but this is some particular module in LangGraph that you need to know how to implement this and how to implement. So everything can be implemented with a code. It's really amazing, right? How great the generative AI is processing. Finally, okay, let's look at the decision making. Lot of businesses using LangGraph to for better choices. It's like having a smart advisor who knows everything and suggesting you the better things. Okay, all right. Now I'm going to show you a small demo implemented using LangGraph framework. So look at this diagram first. You see different parts over here, right? So retriever, wiki search, start and end node. Right? So this is a team of agents working together that performs intelligent query routing between your vector store, that means your database, and the external knowledge, that means your Wikipedia says. Let me explain you the problem statement here. Firstly, we have our router agent. When you ask a question to the model, it decides, do we have the information in our database, or do we need to look up somewhere around? Firstly, I'm going to store some data in my database. If the user comes here and asks some question, first it will try to fetch the information from the database. If the information is not available in the database, then it will go to Wikipedia search and fetches the information for you. Okay. So before showing this demo, let me quickly explain how LangChain works. First, we started by loading the data. And this data can come from various sources, like such as PDF, documents, or websites. Once the data is loaded, we proceed this data dividing it to smaller chunks, in smaller parts. This step is very crucial for processing large amount of information efficiently. And next, we convert these smaller chunks into vectors. So here vectors are like numerical representation of the data. That means we can able to understand the text data, but computers can understand only binary numbers like zeros and ones. Here converting into vectors is like converting into numerical representation of the data. So there are many embedding techniques which converts text into numerical formats, right? And finally, these vectors are stored in our databases. So this storage system means this database enables us to quickly retrieve and utilize the information when needed. Okay. I'll show you the demo now. First, we need to install some specific packages or some specific tools, just like installing applications on your phone. So here I'm installing LangChain, LangGraph, Casio. So LangChain is the main toolkit for working with AI, and then the LangGraph, so which is the current framework, and Casio. This help us to store and find information quickly, which means our database. Casio means also I'm using the AstaDB database here. And here now we are making connections to our database. First, in order to make this connection, I need to go to the data stacks Astra. I need to go to databases and then create database. So as I already created one, so this is my database ID. I just copied this and pasted it here, AstaDB ID, this one. And then I went into generating tokens. I generated token and I pasted it here. Okay. So and next this cashier.init. This is like establishing the connection to our database, like using our application token and our DB ID. I'm just making the connection to my database. So why I created this database? I need to store some of the data into my database. So in this use case, I want to store some information related to agents, prompt engineering, and adversarial attacks. I want to store this information in my database. So I established a connection to my database. And again, I installed another useful package, LangChain community, and then I installed LangChain Grok, LangChain Hugging Face, and then you see this import statement rates, recursive character splitter, web-based loader. So here, recursive character splitter, it breaks text into smaller pieces. Uh, as I already explained to you, like we need to fetch our data first, and then we need to divide our data into smaller chunks, right? So this recursive text splitter help us to break our text into smaller pieces. And next is web-based loader. So these fetches and process web pages. So why I used this means, so I want to fetch information about the agent, prompt engineering, adversarial attacks, and I want to store this information into my database. Okay. So for this, I created a list of web address to fetch the content from. So these, as I mentioned, these agent fetch information about agents, prompt engineering, and adversarial attacks, and I'll store it into my database. Before storing it, I'll use the recursive character text split to divide this data into smaller chunks. Okay. And again, I'm installing Keras. Now, here's the really interesting thing. Like now we want to convert our text into numbers, right? So for that we need to use different embedding techniques. So I'm using Hugging Face embedding. So I imported a mini LM L6 model from Hugging Face. So these embedding techniques acts like a translator. So it is really good at understanding the meaning of the text and converting it to numbers. It has the ability to convert words into vectors. And then I'm creating my database here. So I'm importing Cassandra, that means my database. And then we are we are creating a storage device here with all the details. So the embedding techniques, the table name, and the session key space. And next, I'm creating a vector store index wrapper. So why this means? So the main purpose of it is like we have lot of information, right? So we have lot of information. We want to store them in a way so that is very easy to search later, right? You want to quickly find some relevant information when someone asks a question. So this vector store index wrapper helps me to do that. It quickly helps me to fetch information. And next, this line is really important. This line specifically tells you how you want to structure your output. So creating a retriever object from your vector store and think like creating a specialized search tool that fetches information from me from the database. And finally, I'm giving a query to my database. So I'm asking my database about what is agent. So it can able to fetch some information related to agent from my database. So I got the information like building agents with LLM. It's a core controller, several proof of concept like AutoGen, GPT. It can be framed as a powerful general problem solver. So some specific information related to agent from a database. So this is just a basic setup. Now here comes our LangGraph framework. So I want to set up everything in a graph based here, right? Firstly, I'm setting up the router. So I'm setting up a router here. So this router is a smart system that decides like whether to look for where to look for the answers, whether to uh, look the answers in the vector store or whether to look the answer in the Wikipedia search. And then here this lines of code LLM with function call. So this is where we connect to our AI brain. So I'm using Grok API. So if you don't know what is Grok, like Grok provides faster AI interface with many open LLM sources, LLM models available. So I'm using Gemma 2 model from the Grok so that I can use my LLM. I can set up my LLM here, and then I'm giving the prompt to my model. Like you are an expert at routing a user question to vector store or Wikipedia says. The vector store contains documents related to agents, prompt engineering, and adversarial attacks. And use the vector store for questions on these topics. Otherwise, use Wikipedia search. So if the user query is related to these specific topics, then it will fetch the information from the vector store. That means our database. Or else it use the Wikipedia search. And I'm setting up some other tools, Archive API wrapper, Wikipedia API wrapper. So these wrappers actually, so let's talk about this Archive API wrapper. So this able to search the scientific papers. It gets the top results, and I'm limiting the response to 200 characters. And next, Wikipedia search wrapper. So it searches the whole Wikipedia, and it gets the best matching articles, and also keep responses to short and sweet because I'm limiting it just to 200 characters. And this is the total graph stage management. This is like organizing everything. So it keeps tracks about the questions someone asked, the answers it is generating, and the documents it is founding. And next one is like retriever function. So now I'm creating my agent here. So in my graph, I'm creating a node here. So node is like a agent. So first I'm creating the retriever agent here. So this code actually defines a retriever function. So that takes an input. and it retrieves document based on the user question, which is stored in our database. And next is this is the function, and this is the agent for our Wikipedia search. So it's also similar to this one. First, it gets the user query, and then it searches the entire Wikipedia, and it gives back you a response from the Wikipedia search. And now I'm designing a router node. So the main purpose of this router is to route the user question. So here the LLM model can act intelligently. So based on the question, it will redirect the question to the vector database, or it can able to redirect the question to the Wikipedia search based on the user question. And finally, so now I created different agents, right? Different agent. So now I'm specifying every agent as a node in my graph. So Wikipedia search as a one node, retriever as a node, and I adding some conditional edges. That means our router. And finally, I'm connecting my agents to the end node. So this is the graph. So start, and there are different agents, so retriever and Wikipedia search, and then both of these agents are connecting to the end graph. And here I'll give you the query. So I asking my agent, asking my model like what is agent. See this question is actually related to agent. So my database already contains information related to agent. So it is routing question to the our RAG retriever model. So this the retriever is able to fetch information about our agent. So building agents with LLM, that's the core controller, cool concept. So the agent breaks down large tasks into similar tasks. So some relevant information related to agents. And also next I'm giving the other query like what is Avengers. So as my database doesn't contain information about Avengers, so it is fetching the information from our Wikipedia search. So when I ask it about what is Avengers, so it is giving this the third and the final session of the American animated technology. So based on the Marvel comic series of the same name. So this information is actually fetched from our Wikipedia search. So see like how our AI agents is able to fetch the information, how the router system is working, how it's able to route the system and all. Right. So this is small demo on the intelligent query routing system. Now let's talk about the most exciting part here. Let's understand how we are using AI agents to help healthcare better and better. We might have taken use case like we might have spent hours in a doctor's waiting room filling out long forms about us and about our symptoms over and over, right? So here is the change. Let me tell you this amazing system we are currently working on, the healthcare navigator. So firstly, in this healthcare navigator, firstly we have the intake agent. It's like having a user friendliness instead of filling out boring forms. Uh, you just start normally into this model. So this system able to understand, and if you go to the system and say, so I have a bad headache, and the model asks you the follow-up questions on your query. Like it will ask you follow-up questions like from how many days you are suffering from, did you use any medications, and some similar kind of questions. For and it will finally it able to create a user profile for you. Then the second agent, assessment agent. So this is really clever agent. So you given your symptoms, you answered some dynamic questions. Then it can able to connect your symptoms to possible causes. It checks your medical history. It suggests what test you might need. It's like you if you want. It's like it's suggesting you a doctor's advice, or it's suggesting you some things to follow before you contact your doctor. Finally, the care planning part. So this is my favorite, like because it creates a personalized care plan. It suggests to some medications. It creates a PDF file containing your medical report. So the best part from this entire use case is doctors get a complete report even before they see you, so that they can spend more time actually helping you instead of asking some basic questions, right? So this is just the beginning. So we are seeing AI agents transforming healthcare to make it more personal, efficient, accessible to everyone, right? So Before I wrap up, so let me share something personal. When I first started learning about these AI agents, I was just as new to this as some might of you have been today here. But look how far we came in just some 30 minutes of time. These AI agents aren't here to replace humans, so they are here to help you do things better, fast, and in a more efficient way. Yeah. So thank you. And yeah, so if you are interested in learning more about advanced technologies, please reach out to us and don't forget to explore further about these AI agents. The world of AI agents is growing every day, and what we covered today is just the beginning of what's possible. So there are really big things coming up in the near future, right? Yeah, that's it from my side. Thank you so much.
Thank you for watching. Please like, share and subscribe to KKR Gen AI Innovations channel.